Hi, this is CAD/CAM Lessons channel, and based on this simple part I will show you the basics of 3D modeling in FreeCAD. FreeCAD is a free 3D CAD system for both hobby and commercial purposes. We will create this part in the part design module, where we work on features and parameters, adding subsequent features, defining parameters, and gradually building a 3D solid step by step. Let's start a new project in part design module. Okay, and usually we start work by creating a sketch, and if creating a sketch is the first step, a body object is automatically created. This object is a single solid within which we create subsequent features forming the entire solid. But we can also create such an object by clicking the Create Body button. Click this button and here we have the body, which is an object representing a single solid. Now in this object we can create a sketch. Select Create a Sketch and then define the plane on which we will create the sketch. At this point we can choose the basic planes of the coordinate system, the XY plane, XZ plane or YZ plane, and here select XY plane. Now we have moved to the Sketcher module, where we can create 2D geometry based on which we can add operations to create 3D solids. This module allows us to create sketches that can be linked. We can define the exact dimensions of the geometry and exact position of the geometry relative to other geometry or to the origin of the coordinate system. This method of modeling is very useful when creating technical parts that must have specific dimensions. Now let's create two circles. Select Create Circle command. And I would like these circles to be created so that the center of these circles coincide with the origin of the coordinate system. Here we have coordinate system, the x-axis and the y-axis, and the origin of the coordinate system. And when it comes to drawing a circle, first we define the point where we will place the center of the circle. And as I mentioned, I would like the center of the circle to coincide with the origin of the coordinate system. And to do this, I hover the cursor over this point, and when this point is highlighted, I click the left mouse button, and now the center of the circle has been linked to this point. I place the second point anywhere, and the circle drawing command is still active, so I draw second circle in the same way. I hover the cursor over this point, click the left mouse button and place the second point anywhere. Right click to cancel circle drawing command, and at this point the centers of the circles coincide with the origin of the coordinate system, and I cannot move any of these circles. I can only change the diameter of these circles, but I can no longer change the position of the circle because the center of the circle has been strictly linked to the origin of the coordinate system. This results from the fact that coincidence constraint has been applied here. We have a list of constraints here, and we have two coincident constraints. And these constraints were applied automatically because the automatic constraints option is enabled. And if you follow my tutorials and watch other videos on this channel, I usually have this option enabled, and I also have the option to remove redundant constraints automatically enabled. I usually have these options enabled, and I also suggest you enable these options for yourself. Okay, let's return to the circles, and although I cannot change the position of these circles, I can change the diameter of these circles, and the diameters of this circle are not yet defined. And to define a specific diameter value for the circle, we use the diameter constraint command. Select this command. Next, select the circle and enter the circle's diameter. Here, enter 80 millimeters and click OK. The diameter dimensioning command is still active. Select the second circle and here, as the circle's diameter, enter 150 millimeters and press Enter key to accept. Okay, as you can see, the symbol of the active command is still present at the cursor. The diameter dimensioning command is still active, and to cancel such a command we can do so by right-clicking or pressing the escape key, but also by selecting another command. This command will be cancelled. However, at this point this sketch is completed, so we can close this sketch, and based on this sketch we will create a solid. The basic operation for creating 3D solids in FreeCAD systems is the extrusion operation, and in FreeCAD this operation is called pad. Select this operation, and now, based on the sketch, we add the distance for the extrusion, and in this way we create a 3D solid. Here we have the length parameter, enter here 25 millimeters, and now if you click next to this field, the preview will be updated, and this is how the part will look. Click OK to accept it, and in this way we have created a 3D solid. Now let's move to the Model tab for a moment, and here we have the operation tree, the feature tree, and by adding subsequent features and operations during the creation of the 3D solid, everything will be visible in this place. Here we have the pad operation, which represents the extrusion, and this operation contains the sketch based on which this operation was performed. You can change the name of this operation. You can do this here in the Label tab. You can enter a new name. Okay. You can also select the operation in the operation tree and press F2 on your keyboard, and here we can also change the operation name, or we can simply right click and select rename. Each of these options allows you to change the operation's name, and in the case of more complex projects, defining your own names can facilitate model management, because if you later need to make some corrections or changes, defining your own names can make it easier to locate the selected places where we need to make changes. Okay, we have such a simple solid here, and working in 3D systems very often involves creating 3D models in stages. First we create some basic feature, then we add subsequent sketches and operations to expand the model, and this is also how we work in the part design module, simply building the model in stages. And now, to add the next stage, we can create another sketch, and such a sketch can also be created on the faces of the solid. Now we will create another sketch on this face, and to create sketch on this face, select this face and select Create Sketch. Now this face is the sketch plane, and here I will also create two circles in such a way that the centers of these circles coincide with the origin of the coordinate system. Select Create Circle and create two circles. OK, right click to cancel this command, and I would like the diameter of this circle to be 100 millimeters, so I select this circle, select Constrain Diameter and enter 100 millimeters. OK, and as for the diameter of this circle, I would like it to be the same as the diameter of this circle, and in this case a better solution than defining a specific diameter value for this circle would be to link this circle to this part of the solid. And to be able to link some sketch geometry to the previous stage of the 3D solid, we need to create reference geometry. And we create such geometry using the create external geometry command. Select this command and select the geometry based on which we want to create the reference geometry. Okay, now right click to cancel this command and select this circle and select equality constraint. And now these two diameters are equal. And this constraint defines that these two diameters are equal. Here I don't need to enter a specific diameter value. This diameter will be linked to this part of the solid. Close the sketch and add another extrusion here. And enter 100 millimeters as the extrusion length. Okay. And as you can see in the operation tree, another feature has appeared. We have the second extrusion operation, and by creating the 3D model in such stages, step by step, more features will appear here. And if we later need to make some changes to a selected operation, we can easily do it. We just need to edit the selected operation. For example, if I want to change the length of this extrusion, I can easily do so. I just need to double click here with the left mouse button and enter a new value, for example 30 millimeters, and click OK, and the changes have been applied to the solid. Similarly, we can make modifications to sketches. We can also edit such a sketch. Double click here with the left mouse button to enter sketch editing mode. And as for modification in sketches, we can change dimensions here. We cannot create new geometries or editing existing ones. We can only change dimensions. For example, change the diameter of this circle to 170 millimeters. Okay, close the sketch, and the changes have been applied to the solid. This is very convenient because if we create a part and it turns out that we need to make some dimensional changes, we only need to edit the selected operations and we don't have to design the entire part from scratch. Okay, now let's create another sketch. We will create a sketch on this face. Select this face and select create sketch. And here I will draw a circle. I would like the center of this circle to lie on the y-axis, so I hover over the y-axis, and when the y-axis is highlighted, I click the left mouse button and draw a circle. Then I add the diameter of this circle, 9 millimeters, okay, and add the distance of the circle's center from the origin of the coordinate system, and here enter 65 millimeters. And when creating 2D sketches, it is worth noting that the sketch is fully constrained. A fully constrained sketch means that we cannot freely change the position and dimensions of the sketch by dragging it. Here we have strictly defined the position and diameter of this circle, and if I want to change something now, I have to do it consciously by editing the dimensions or constraints. And let's aim for the sketches based on which we create the 3D solid to be green and fully constrained. Okay, close the sketch and add the next operation, which will create a hole in this solid. This is the pocket operation. Select this operation. And now we define the pocket depth. And regarding the parameter in this window, we can enter a specific value here, but we can also rotate the mouse wheel and the parameter value will change. And we also have a type field where we can specify, for example, through all. And now the hole will be made through the entire solid. And click OK. because this is what I wanted, and we have created such a hole. Then I will create another sketch on this face, select this face and select create sketch. Here use the create external geometry command to create reference geometry based on this circle, because I would like to create another circle here whose center will coincide with the center of this hole. Select create circle and place the center of this circle in this point and draw a circle. I used the automatic constraints, placed the center of this circle in the center of this hole. Let's add the diameter of this circle and enter here 15 millimeters. OK, close the sketch and add another pocket operation and enter here 10 millimeters as the depth of this pocket and click OK. And we have created such a hole. And now I would like to create 10 such holes evenly spaced on this solid. We could draw this, we could create a sketch for each of these holes, we could do this in 10 sketches or we could do it in one sketch, but we can also use the circular pattern operation, which will significantly simplify the creation of such features. These operations work in such a way that it simply creates additional copies of the selected feature around the selected axis. In this case, I would like to add a circular pattern of two operations that created these two holes. To do this, select these two operations with the Ctrl key in the operation tree and then select polar pattern command. And here, as you can see, we have the number of occurrences. We currently have 2 occurrences, and we will return to this in a moment, but I would like to show you what happens if we select only one feature. Let's cancel this for a moment, and I'll select one feature only and select polar pattern. And here, as you can see, I only selected the last feature in the operation tree and the circular pattern was only performed for this feature. Now I cancel this and select these two features again and select polar pattern. OK, and now let's start with the number of occurrences. Here by default we have 2 occurrences, but as I mentioned, I would like to have 10 copies of these holes, so I enter a value of 10 here. OK. Next we have the angle parameter. Here we have entered 360 degrees, and we will return to this in a moment because we also have the axis parameter, which defines the axis around which the circular pattern will be performed. By default, the normal sketch axis is selected. In this case, this axis coincides with the base z-axis, so selecting the base z-axis or the normal sketch axis will achieve the same effect, and the circular pattern will be performed around this axis at a specified angle. Here we have entered a value 360 degrees, so 10 copies of specified features will be distributed around the indicated axis at an angle of 360 degrees. If I change the value here, for example, 180 degrees, these 10 features will be distributed at an angle of 180 degrees. Here I will return to 360 degrees and click OK to confirm. OK, and another basic operations in creating 3D solids is rounding and chamfering edges. These are very simple operations, and rounding and chamfering can be added to a selected edge, several selected edges, or we can also indicate the entire face to add a chamfer or rounding. And let's add a rounding in this place. Select this edge, select the fillet command, and here define the rounding radius, enter 3 mm here and click OK to confirm. In this way we can add chamfers and roundings to one or several selected edges. If you want to add, for example, a chamfer to several edges, you can select these edges with the Ctrl key. For example, select these two edges with the Ctrl key and select chamfer operation. Here define the chamfer dimension and click OK, and the chamfer has been added to the selected edges. However, if we want to add, for example, a chamfer to the outer edge of this solid and the edges of each hole, there would be quite a lot of selecting. But chamfers and roundings can also be added to all edges of the selected face. If you select this face and select chamfer command, the chamfer will be added to all edges on this face. Here we define the chamfer dimension 1 mm, click OK to accept, and with these few steps we have created such a part. And note that all steps are included in the operation tree. We have a complete history of creating this solid. And now if we need to change something, for example, I want to change the diameter of this hole, I simply locate this operation, OK, and go to sketch editing and change the diameter of this hole from 9 mm to 12 mm. OK, click close, and now the diameter of all holes have been changed. And creating 3D models in this way, where we work on features and parameters, can be a very good method for creating 3D models that need to have specific dimensions and shapes. And by creating models in this way, we have a clear history of operations and we can easily make modifications to the dimensions of previously added operations. If we design a part that will be later manufactured and it turns out that we need to make some minor dimensional changes, we don't have to design the entire part from scratch. We can simply use what we have and edit the selected dimensions. And creating this solid, we discussed the most basic operation for creating 3D solids in FreeCAD systems, and another basic operation for creating 3D solids based on a sketch is creating a solid by rotating the sketch around the selected axis. Now let's create another project in FreeCAD. Okay. Let's create a sketch, and this time select the XZ plane as the sketch plane, and here we will create a cross-section sketch that will be used to create a solid by rotating the sketch around the selected axis. We will create a shape consisting of several lines, and when it comes to drawing lines in FreeCAD, we have the line command. And this command works in such a way that we draw individual lines. Now, if I want to create another line linked to this line, I click here to link the start of the new line to this point and define the second point. In this way, I can create subsequent segments of the sketch. Here I remind you that I have automatic constraints enabled, which allows me to link the next line to the end of the previous line. However, drawing shapes consisting of several lines in this way is not entirely convenient, and a better method may be to use the polyline command. I will delete this geometry. OK, I select the geometry and press delete key on the keyboard. Now select the create polyline command, and with this command we can draw a shape consisting of several lines. Okay, I'll delete this geometry and let's again select create polyline, and here we will draw a shape that will be used to create a solid by rotating the sketch, and the first point will be linked to the x-axis, and when the x-axis is highlighted, click the left mouse button and we have the start point of the polyline. Now draw the shape more or less in this way. Now I want to create the next segment of this shape, and automatically the next segment of the polyline is linked to the previous segment of the polyline. Now let's draw something like this to get a shape similar to the one we create in the previous example, and here I want to link this point to the x-axis. Therefore, when the x-axis is highlighted, click here, and now I want to link the last point of the polyline to the first point of the polyline. So when this point is highlighted, click the left mouse button here to finish drawing the polyline. Now right click to finish drawing the polyline, and right click again to cancel the polyline drawing command. Okay, now let's move on to adding dimensions. First let's add vertical dimensions. Select this command and select this line, and here enter 100 millimeters. Okay. Now click this line and here enter 25 millimeters. Okay. Now select horizontal dimension, and just as we indicate geometry here, we can also select points between which we will add dimensions. Select this point, and here enter 40 millimeters. Okay. And now select this point, and here enter 80 millimeters. Okay. Right click to cancel this command, and here grab this point and move this line a bit. Okay, and select again constrain horizontal distance, select this line and enter here 10 millimeters. Okay, we have created such a sketch. The sketch is fully constrained, meaning we cannot freely change the shape and position of the sketch. Close the sketch, and now based on this sketch we will create a solid by rotating the sketch. And to do this, select the revolution command, and here, as you can see in the preview, the solid looks like this, and we have a sketch revolved around the vertical axis of the sketch. In this case, the vertical axis of the sketch coincides with the base z-axis. Here we can choose another axis, but it won't be what we wanted to achieve, so let's go back to the vertical sketch axis. Okay, and here we have the rotation angle. We have the sketch rotated at a full 360-degree angle. If I enter a different value here, for example 180 degrees, the solid will be created in such a way that it will simply be an incomplete solid. Let's go back to 360 degrees. Okay, and click OK to accept it. And in this way we created a similar solid to the one we had in the previous example. Now if you want to edit something here, we can simply edit the sketch on which this solid was created. Go to the sketch editing, and for example we can increase the outer diameter to 120 millimeters. Close the sketch, and the changes are applied to the solid. And now on this part of the solid we will create holes, and we could do it as before by creating a whole sketch, adding a pocket operation, then creating another whole sketch, adding another pocket operation, and then using a circular pattern. However, in this case we will do it a bit differently. We will also use a circular pattern, but we will create the hole using the hole wizard. And to use the hole wizard, we need a sketch to define the hole's center, and we create this sketch on this face. Select this face and select Create Sketch. And here draw any circle whose center will lie on the y-axis. The diameter of this circle doesn't matter because this circle only defines the hole's position. And now let's add a dimension for the hole's center from the origin of the coordinate system, because this is important. Select this dimension, select these 2 points, and here enter 80 millimeters. Okay. And as for the diameter, in this case I don't have to dimension it. We can do it, but we don't have to. Close the sketch and now select the hole command. And based on the sketch we created, the hole's position is defined. And as for the hole's shape, we can use standard holes. Here as the profile, select isometric regular profile. As the size, select M10. And as the type, select counter bore. And this way, using standards, we defined the hole's shape. The sketch we created earlier defined the hole's position, and this way we created such a hole. Click OK to accept, and now using a polar pattern, we can replicate this hole on this face. Select this hole, select polar pattern, and specify number of occurrences, for example 10. As for the circular pattern axis, the default selected axis is correct, and the 360 degrees angle is also correct, because we want to distribute these holes around the entire solid. Click OK to confirm, and this way we created a solid similar to the one we created in the previous example, but in this case we used slightly different method. The operations you learned in this tutorial are basic operations for creating 3D solids in FreeCAD systems, and knowing only these operations, we can already start creating our own 3D models in FreeCAD systems. And we will end this tutorial here, and if you want to learn more about creating 3D solids in FreeCAD, you can check out other videos on this channel, or you can also use my FreeCAD 3D modeling basic course, the link to which you will find in the description of this video. It is a video course in which I discuss basic topics related to creating 3D models in FreeCAD. Thanks for watching, and please subscribe to this channel.